So we have Maxim Khlobystov, Oleksandr Zhurbenko, Perrone, and this is the, I'm told specifically to mention this in case any of you are actually in the wrong room. This is migrating BigBlueButton to HTML5. Now, these three guys are from CDOT, Centre for Open Source Development, which is in Seneca College, where we, or where, not, I say we, I'm retired, but where a group of people teach various aspects of open source integrated into various courses within the college, and where we employ students in the back end of their time at Seneca. We actually employ them to extend their time and do research on open source products, many of which exist in the market. And BigBlueButton is one of those. We didn't write the original, but we've been working on it for a long time, and on and off different series of projects as the years go by. And the latest one is to import, not import, but to modify it to use HTML5, which I believe is instead of Flash, right?
Yes, that's the goal.
Will it do both, or?
It's a separate client, additional client, like
Sorry?
additional client to the Flash
Okay.
client.
Oh, so the service itself then will do both, but obviously HTML5 is open, and always a good thing, otherwise we won't be able to come to one of these festivals every year. Okay, so.
Hi everybody. I'll start with a short overview of BigBlueButton and explain why and how we decided to migrate to HTML5. BigBlueButton project started in 2007 in Carleton University as a master's project of one of the current contributors. The initial purpose was to allow remote students to participate in studying, as at the time they were using an expensive commercial product. Since then, project grew up. We've had 12 major releases, and last month we finally reached 1.0 beta. I did these screenshots yesterday. Maybe we have a bit more commits or forks, but during the last 8 years, we got more than 11,000 commits made by people from almost every continent in the world, and more than 2,700 forks. BigBlueButton's localization covers more than 90% in 60 different languages. The goal of the project is to provide every student a high-quality learning experience, high-quality online learning experience. And we intend to do this with BigBlueButton. This is our main client, Flash client, Flash-based. There are just two roles in the client. You can be either a presenter or a viewer. If you're a presenter, then you have access to desk sharing. You can upload the presentation, PDF or PowerPoint. You can go through all slides. You can write shape, some figures or shapes right on top of your slide if you want to highlight your point or just draw something. The features which are available to both roles are sharing audio, webcams, and public and private chat. At some point, we decided to create an alternative way of how people can access the system, as Flash really shouldn't be the only way people can access BigBlueButton. But we want our HTML5 client to be developed in parallel with Flash. This means that people still want to see new features in the Flash client and the main client. And HTML5 version of it is supposed to catch up at some point, and maybe eventually we'll replace Flash with HTML5 and make it our main client. To reach this goal, we have to go through 3 main versions of HTML5 client. The first version we released in May. It's a stable, ready-to-go HTML5 client, but it covers just the viewer perspective, of the client. The second version, the next one, will include video and desk sharing features. And the last main iteration will have all of the presenter functionality features. This is not our first attempt to create an HTML5 client for the BigBlueButton. It's actually the third. But first 2 were more than like proofs of concept, maybe. They were simple Node.js apps, and we had a lot of problems building them. We had a lot of custom code there, and we had to implement all the data synchronization and communication between client and the server ourselves. And it took too long to implement even a simple feature. For example, we had just 1 person working on the Flash client and 3 people working on HTML5, and features in the Flash client appeared faster than in HTML5. The way it was, HTML5 client would never catch up Flash. But then we found Meteor. Meteor is a solid open source framework which extends Node.js and MongoDB. And it has his own package manager with a lot of different packages. And its main strength is its real-time updates. So the way it works, Meteor runs a main MongoDB on the server side, and it also has a local mini Mongo on the client side. And every page Meteor serves is an actual handlebars template, which is synchronized with the server. So when you change anything on the server side, Meteor synchronizes your local database with the server side database, and then it changes your template. It made it so simple to implement new features with Meteor that so that although we have a previous app in development for more than a year, we were able to start from scratch and to get the same functionality in roughly 4 months. The other big piece of technology we use in our project is less. At some point, our CSS code base became too big. We had around 5,000 lines of code, and we switched to less. 3 main things we use from less is nesting, variables, and mixins. Nesting means that if you want to refer to 2 different child elements in CSS, you have to actually write 2 separate blocks of code, or 3, or yeah, depends on the number of elements you want to refer to. But in less, you can refer to all of them in the same block of code. Variables and mixins are basically code reuse, and they allowed us to reduce the amount of code we have. Raphael.js and Redis are the last 2 technologies we use in HTML5 client. Raphael.js is a lightweight JavaScript library which is designed to work with SVG animation. Frankly speaking, there are a few more SVG wrappers in the web, but we chose Raphael.js because of its excellent browser support. It works even in IE6. At some point, we had to start communicating with the rest of BigBlueButton, with the other components and clients. And we already had Redis in our project, and we found that it implements a standard publish-subscribe paradigm. It means that there are channels, and clients can subscribe and publish those channels without knowing who received their message. And when somebody publishes anything to the channel, Redis handles that message and makes sure that all of the subscribers receive it. And this is how we implement the communication within BigBlueButton. We send, publish, and subscribe to JSON messages. These were main technologies used in HTML5, and Maxim will talk more about the actual development problems we faced during the development.
Yes. Alex mentioned that that we use a variety of different technologies in BigBlueButton, and a good example of a place where we apply those technologies is the UI of our HTML5 client. First of all, the UI is our HTML5 client is multi-platform, and that means that we're trying to make it work as fast, as user-friendly, and as reliable on a mobile device as it does on a desktop computer. And when it comes to development for mobile browser, for actual mobile browser, you need to consider a few things. First of all, you really want to provide a consistent experience between different browsers, between different devices. So that means if one feature, for example, desktop version of your application has some feature, that feature must exist on any other device and behave in some similar way. And at the same time, you really need to have a way to adjust your UI to each specific case based on the device type, the device size, device resolution. The CSS feature that we did it using CSS, through CSS, and CSS feature that allowed us to control our style sheets in that way is called media queries. Media queries basically provide this set of predefined objects as well as the associated conditions that the developer can check for in an application. And those conditions can be based on such things as they're tied to a device, and they can base to such things as like resolution of the screen, or aspect ratio, or even orientation of the device, is a portrait or landscape. And each of those conditions is still quite limited, but in order to achieve your goal, you can mix and match them. Our usage of media queries actually evolved over time. And first, we had only a desktop version of the client, so desktop view. And you can imagine that it worked really well. It was stable, but as a version of the client that designed specifically for a desktop, you can imagine that when you enter the meeting from a mobile device, in a landscape view on your small screen phone, all the elements just looked really extremely small. And at the same time, when you handled device in a portrait view, the horizontally oriented UI just didn't make any sense at all. So that's when we realized that we need to add some more views to our application, and we separated the desktop view, and we separated the portrait view and the landscape view, and at the same time we learned how to detect the mobile device. So we basically, at that point, we had 4 different views for a desktop, for mobile, and for a landscape and portrait for each of them. But it was actually not enough. You can imagine, let's say I have a phone, 5-inch phone, and also a tablet, which size is, let's say, 10 inches, so twice bigger. And we ask ourselves a question: do we really need to see the same button covering the same percentage of the screen on both devices, on a small device and twice bigger device? No, right? Because in that case, the button would be either too large on your tablet or extremely small on your phone. So we also we desperately needed some separation, not only between desktop and mobile, but also within the mobile devices. So we needed to separate our style sheets, the tablet and phone views. We did it using the same media queries, but in that case, we used what is called CSS pixels. Those are different from the regular pixels we all used to see any specifications of the device when you're buying a new device, for example. And we all know that the resolution pixels that are in the specification are, in our case, pointless, because these days, devices, completely different devices with different physical sizes can have quite similar resolutions. But we needed to rely on the actual physical size. And CSS pixels are designed specifically for mobile developers, and as a result, they are based on the actual physical size of the device. So basically using the CSS pixels allowed us a guarantee that the resolution of the tablet, the bigger device, will always be bigger than the resolution of the phone, which is much smaller. You can see that we are trying to use really cutting-edge HTML5 technologies here. And in such cases, sometimes new features backfire. And first of all, they can affect the compatibility between browsers. So you may lose support for some of the browsers. You need to recover your application. In our case, in that case, you really need to be patient, and you need to be careful and of course patient, because in most parts that means that you need to write the same code, but for each of the major browsers, like 3 times, for example. The good example of that on our end is what we call the full screen mode. In HTML5 client of BigBlueButton, you have an option of going to a separate view where you can only see the presentation itself and listen to the audio, and that's it, without any unnecessary distraction. So it's some sort of no distraction view, similar to what the YouTube website has with the videos. You can just watch and listen, and that's it. In order to implement that, we used the full screen API, which, as for right now, exists only as an extremely early draft of HTML5 specification. And that means that all the browsers support it, but they do it differently. And that basically means 2 things. That means that there are differences in naming conventions. So the functions and the events, for example, all the variables that you use from the API have completely different names. So you need to write similar code, but with different naming conventions. And that's even not the worst problem. The worst is that the implementations themselves can differ. And that means that you not only need to copy-paste your code and change the naming, but also the behavior of the function can be different. In the case of full screen API, for example, we have events that are triggered every time something happens with the interaction between the user and full screen. For example, the user enters the full screen mode, and some event is triggered. And in Firefox, from our experience in Firefox and the Chrome, those events just need to be applied to different elements. So that makes the idea of one implementation, even with different naming, but one implementation just impossible. So you really need to write 3 different functionality for each of the browsers. And another important aspect of HTML5 development that needs to be considered when you're transitioning to the mobile is also performance. And in our case, we faced a performance challenge when we were implementing the feature that we call sliding menu. Just a little of background here. Of course, we all know that the space is very valuable on the mobile devices. And in BigBlueButton, we have 3 modules. So it's a user list, a whiteboard, and the chat. And we couldn't really fit all of them on the mobile screen by default. So we decided to put only whiteboard and chat, and the user list, and also the list of options available, we put it on an offset menus. So it's a menu that is hidden by default, but by clicking the button, the hamburger button, you can just trigger the menu. And also, we all used to such kind of menus, the offset menus that slides from the side. And we used to see those on native applications to mobile devices. So we really wanted to implement, to provide the same kind of experience to user. And the native versions of those menus usually have animations. So we added animations as well. And that's where we had some sort of a performance problem, performance challenge. First of all, since we have a HTML5 application, we used jQuery a lot, and it was obvious. It's just what we just implemented the first implementation of this sliding menu. We did it through the jQuery, through the animate method in jQuery, and we noticed that it worked really slow, and we couldn't do anything with the performance of that. That's when we switched to CSS animations. CSS animations are much faster, and there are a few reasons for that. First of all, there is the GPU acceleration. So the hardware is trying to basically separate each animation, trying to put each animation to a separate GPU layer. And in that way, it can be performed in parallel with everything else. And as a result, it's obviously performed much faster without any unnecessary interaction with anything else. And also, since we moved our animation logic from the JavaScript to CSS, there's no memory problems anymore, because there's no garbage collector and no more memory overhead in that sense. And also, CSS animations implement what is called the request animation frame principle. And that's basically browser's way of optimizing animations. The browser is trying to combine closed animations by putting them together into one unit and perform the rendering of that unit into one repaint cycle. So that means the browser needs less repaint cycles to perform the whole animation. Yeah, so just basically don't forget that even though our gadgets are quite powerful nowadays, since still the desktop computer, something can go really fast on desktop computer, but not on a mobile device. So you need to do some performance adjustments. And that was a short overview of the challenges of our experience of development features in BigBlueButton for a BigBlueButton HTML5 client for the last year or so. And those features are already implemented. And Danny will talk more about the future features, the future of BigBlueButton HTML5 client.
So as Maxim said, those are all the features that we currently have inside our client. And so now I'm going to discuss the features that we are currently developing and hoping to get in real soon. So we're currently trying to roll out features that will make the HTML5 client more of a full-fledged client and make it an equal competitor with our Flash client, and so they can both be on par, because currently before, the HTML5 client lacked some features that you just wouldn't be able to get, and the Flash client would always be your choice if you want some of those features. So we're currently implemented some presenter features, and there's always more presenter features being added, so you can have more control over a presentation if you are presenting through the HTML5 client. And the key feature I'm going to discuss is HTML5 video, and that was the key feature we were lacking that the Flash client had, and that is coming to an end now, and that's what I'm going to be discussing. So specifically with HTML5 video, it is the presenter screen. So with the Flash client presenter, they can share their desktop, and they can also broadcast webcams, and previously the HTML5 client wouldn't be able to receive that video. And that's because the Flash client was, for the most part, the only client that was meant to see this video, and because of that, it was in a format that was viewable only by Flash, and at the time, that was acceptable. But now with HTML5, we have to have a different way of delivering video that the HTML5 client can display. And so this feature is done thanks to a technology called WebRTC. And so that stands for Web Real-Time Communication. And so it is, it's an API, and it's implemented by the web browser. And what it does is it allows for browser-to-browser or peer-to-peer communication. And it is secure communication, and this communication is done, it's in the browser, and it can be done with only JavaScript. So that makes it perfect for our HTML5 client. You don't have to have additional plugins or any other type of add-on or any other type of technology. It can be done through an HTML page with pure JavaScript. The next big component in receiving video is FreeSwitch. So FreeSwitch is an open source project, and it is a software telephone switch. It's a core component of BigBlueButton already, and it's what we use for the audio mixer. So in a BigBlueButton meeting, many people can share or receive audio. And what happens is all the different users, they can send in their different audio streams from their microphone or any peripheral. And what will happen is it'll get sent to FreeSwitch, and this audio mixer, it will combine all the audio streams into one stream and send that stream out. So instead of some other type of telephony software where everyone shares their individual stream to each peer, they all get sent to one local server or one server. Then that server will mix it and send out one stream. So it's much more efficient than if all the peers were communicating. And FreeSwitch has their latest release, 1.6, they now support video. And they do something similar with video. And so what they have accomplished is many people can send in a video stream to FreeSwitch. And what FreeSwitch is going to do is, instead of relaying the individual streams to each user, is on the server side, it will combine all the streams. It will tile each of the video streams into any layout that you wish, and then it will send out one video stream. Because previously in other video implementations, all the individual streams would get sent to the server, and then it would relay it. But then that meant you had a video stream for each video stream that you received was its own video stream, which created a lot of overhead. But now you can just receive one video stream. And the next big component of receiving video is a component of FreeSwitch, and that is called Modverto. So Modverto is a FreeSwitch endpoint. And what it does is it allows you to use JSON and send messages and receive messages to the FreeSwitch server using secure WebSockets. So their initial target is WebRTC, and the purpose was to simplify coding and implementing calls from the web browser and other devices directly to the server. So with WebRTC, we can have a call originate from an HTML5 web page, and it'll connect directly to the FreeSwitch server, and is just done using JavaScript and JSON messages. And what this allows us to do is it allows you to share all web browser supported media. So in this case, desktop sharing or sharing your screen, we can capture that and send it to the FreeSwitch server. So screen sharing was the main purpose of implementing video into the HTML5 client. And so this started with the web browser. So this is still a fairly new technology. It's fully supported by Firefox and Google Chrome, but it's still a relatively new feature. And they both handle them fairly differently. So with Firefox, for example, we've created a web browser extension for both Google Chrome and Firefox. And so with Firefox, for example, I had to make a extension, and what that extension does is it will set different flags in Firefox that will allow you to share your screen. And you also, for security reasons, have to add your domain to a whitelist, so that way a rogue web page cannot just try to broadcast your screen to their server. And once you've accomplished that, you can just access the screen sharing API just like any other JavaScript API. With Google Chrome, though, it's a bit different, because with Google Chrome, they have implemented screen sharing as an extension level API. So what this means is you have to have an extension that will enable screen sharing. It will also add your domain to a whitelist of allowable domains, but you also have to have the extension as a communication layer. So what will happen is your web page will communicate with the extension. It will send messages back and forth and say that it wants to request the user screen. And so that extension will then receive that message and communicate with Google Chrome itself, the extension level API. And then that extension API, if the user has enabled the correct permissions, then it will request permission from the user. So the user will be able to select what they want to share. And then it will send it to the extension, then the extension needs to communicate it back to the web page. And so that you're able to do that locally. But now what we wanted to do was take that video and send it off through WebRTC. So once we've obtained permission from the web browser and obtained a screen, we can make a WebRTC call. So just like we would make a WebRTC call with a microphone or requesting a web camera, we have a screen. So we can pass that as just like any other piece of hardware. And then from our client JavaScript, we would connect to the FreeSwitch endpoint, modverdo. And then modverdo would connect us to FreeSwitch. And then FreeSwitch, it would receive our video stream, and it would receive any other video stream that is being shared to the server, and it would mix them all together and send us back that one video stream. And that one video stream is HTML5 compatible. And so now in our finished product, we can send and receive WebRTC audio, webcam video, and desktop video. So the main purpose of this was the desktop video being sent from a Flash client, and this is now implemented. But we also have the ability now to share and broadcast your screen from the HTML5 client, and once we have receiving fully ready, we can begin working on these other presenter features like broadcasting. And then eventually when other video streams get added, such as webcam, when they get shared over WebRTC, we can receive them without having to make a change, and we can also have support for audio. And through this, using the modverdo endpoint on FreeSwitch, it forces secure communication, because modverdo forces you to use secure WebSockets. So because of this, we now had to serve the HTML5 client from HTTPS and use secure sockets. And now, as I said, with FreeSwitch 1.6, the video mixing, it's much more efficient video streaming, because instead of having to receive an individual video stream for each video stream you want to display, and the overhead of creating each new video stream, we can just receive one stream, and all the processing is done on the server. And another important feature of this was automatic reconnection. Through using the secure WebSockets, modverdo can automatically reconnect if a call was dropped. And so that saves a lot of programming time for us, we don't have to worry about a video stream or an audio stream being dropped. If it gets dropped, Modverto will automatically reconnect it for us. And so now that is desktop video, and it is now being sent to the HTML5 client, and that was one of the last few major components that we want to have in the HTML5 client. And so now we have that, and the HTML5 client is much more an equal competitor with our Flash client. And these are the important links for the BigBlueButton project, our GitHub repo, our documentation, and our public demo for BigBlueButton.
Questions?
Are there any questions? Yes?
I couldn't wait for your finished call. Your project timeline, where are you now and your goal, and when do we expect to see it done?
Well, the HTML5 client is now publicly available for testing on the last link, our public demo. We have all our source code available on the first link, and our beta has been released and is available for testing now, and it is being tested now. And once testing has been completed and we no longer have major issues, we can try to schedule a release. Yes?
I don't understand how you fit into the big picture of the BigBlueButton owners and their product development and enhancement plans. How do you communicate and interact with them both from a communication point of view and integrating your code and plans?
How we communicate with the developers of the Flash client and the BigBlueButton project?
Yeah.
Through CDOT, we work with them very closely, and we communicate with them every day, and we give them updates on our client, and we communicate all changes back and forth between the BigBlueButton server and the framework and our HTML5 client, and we go to visit them a few times a year and have lots of back and forth communication.
So where are they located?
They are located in Ottawa, Blindside Networks.
And how many people are there on this project?
There's a dozen or so people working on that client and Blindside Networks. And then the HTML5 client consists of myself, Maxim, Alex, and one of the workers for Blindside Networks. Any other questions? Yes?
Now that you've got beta, have you found any interesting bugs?
No. We found some issues with data synchronization due to a large audience of people testing, and that was just something that we had never experienced before with local testing. But now on a public server, we have people who can test it for us and can run it for several days and inform us of any bugs, and we are currently addressing any issues if there are any, and then when we see fit, we can move forward to a proper release. Any more questions? Yes?
If anybody wants to contribute to the project, do you accept actions on the GitHub?
Yes, of course. So the first link there is the BigBlueButton repository for the BigBlueButton account, and our documentation is on the second link, on bigbluebutton.org, and we have all the documentation prepared for anybody who wants to set up a BigBlueButton server and for anybody who wants to begin development. And it tells you all the steps to submit a pull request, submit a bug, and just how to develop and set it up. And then, so you can visit both links, and you should have all the information you have, and then you can contribute to BigBlueButton. Anybody else? Well, thank you for listening.